Okay, so which section is that?
1.6.
Section 1.6. And what's the problem? 23?
Yeah.
Okay, what does it say?
It's the limit as x goes to -4.
The limit x goes to -4.
And then it's kind of a big fraction. It's 1 over 4 plus 1 over x.
1 over 4 plus 1 over x.
All over 4 plus x.
All over 4 plus x. Okay. Notice that if you plug in -4 for x, what would happen? You're going to get 0 divided by 0, right? And so, what did I say about that? Yeah, I mean, you have to factor out, but this is not we don't have a polynomial in the numerator, so you cannot factor it out. However, what is giving you 0 in the denominator? 4 plus x, right? And so you should be trying to get rid of that when you get 0 divided by 0. Now, you look at this problem, even if you have no clue, like what to do, what would be the next step? Say you don't have any clue, and my advice to you is that do the obvious algebra. So what's the obvious algebra here? The obvious algebra here is that you have two fractions in the numerator. Well, simplify that. Am I making sense? Is everybody okay with that? So what we are going to do is we're going to look at the fraction 1 over 4 plus 1 over x divided by 4 plus x, and then we are going to see how we can simplify this. So there are a couple of different ways, but let me just do the following. In the numerator, I have two fractions. What should be the common denominator? 4x. And then I am adding them, so I have a plus in between, right? Then there is a numerator. So there is a, let me use some other color, green. There is a numerator 1 here, right? So 1 would be multiplied with something. And then there is another numerator here, 1 multiplied with something, right? So what goes here in the first parenthesis? What goes in the first parenthesis? X. And in the second one? 4. So what are we getting then? We are getting x plus 4 divided by 4x divided by 4 plus x. And notice that in the denominator, when I have 4 plus x, it really means this, right? Okay, so when you have something like this, what do? Yeah, you simply say that this is x plus 4 over 4x multiplied by 1 over 4 plus x. Notice that there is no difference between this one and this one. So all I get is 1 over 4x. Is everybody okay? Alright, so let's go back up. The limit that we wanted to compute was this limit. Now I could say that this limit is the same as the limit x goes to -4 of 1 over 4x, and so that would be what? 1 over -16, right? When you plug in -4. Is that making sense? So once again, I really didn't have to know a whole lot about this. All I had to do was that I saw there is some opportunity to do some algebra. I do that algebra and see what happens. Simplify. That's why we did all that review of algebra, simplifying expressions, stuff like that. Is that making sense? Okay. Any other questions? Any other questions, anybody? We have done all this. Unfortunately, yesterday my video lecture was deleted, and so you won't be able to find it in Moodle. But you're gonna find whatever I do today. Okay, is everybody doing okay? Any questions at all from the homework? Any other problems? Oh, if I were you, I would be making sure I'm asking a whole lot of questions so that no new material is covered. Right? Okay, now he has questions. Okay, go ahead.
It's the limit as x approaches 5.
What was the number again?
13.
13. In what section?
1.6.
1.6. Is it a limit again?
It is a limit.
Okay, x goes to?
5.
Okay.
It's x squared minus 5x plus 6.
X squared minus 5x plus 6.
All over x minus 5.
All over x minus 5. Okay, so let's see what happens. What's the limit of the denominator as x goes to 5? 0. What's the limit of the numerator? 0 as well? Oh, what am I saying? If you plug in 5 there, you get 5 squared, so that's 25 minus 25 plus 6. So this, what you get is the following. Let me. So this numerator has limit 6, and the denominator here has limit 0. So what did I say when that happens? What would be the limit? Would be either plus or minus infinity, right? Now I have to determine what's the sign. When x is close to 5, the numerator is obviously close to 6, so therefore the numerator is positive. And how about the denominator? Is there a 5 from the right or left in the question? No? Okay. So then notice that the denominator here, where is that? Draw. The denominator here, when x goes to 5 from the right? When x goes to 5 from the right, what's going to happen? This would be positive, right? But if x goes to 5 from the left, the denominator would be negative. So I see that depending on how x is approaching 5, the limit would be infinity or negative infinity, right? So I'll just say that it doesn't exist. Is that making sense? So we'll just say that it doesn't exist. So you can just write dne. What was that? Yeah, dn. You're going to write dn. Okay, but if it was just positive infinity, then you write positive infinity. So for example, if instead of having x minus 5, if I had the square of that, right? Now notice that it doesn't matter how I approach 5, my denominator is just positive. So then the answer would be positive infinity. Is that okay? All right. Any other questions? Yeah.
29, 1.2.
29, and you have another limit, I assume?
Yeah, as x approaches 0.
As x approaches 0.
Of the quantity 1 over x times radical x plus 1 minus
Radicus
minus 1 over x. 1 over x.
Minus 1 over x in the denominator, or right?
No.
Yeah. Right this?
Yes.
Okay. This was in section 1.6, okay. here, once again, you probably wouldn't, when x is 0, obviously, what do you have? You have 1 over 0 minus 1 over 0, right? But it doesn't tell you what the limit is, right? You realize that? As x goes to 0, for example, because it's not a plus or minus, right? Okay. So as x goes to 0, each term could be plus or minus infinity, right? But we don't know which one. And then we are subtracting, okay? So we don't know what the limit is. Even if I know that the limit of the first one is infinity, the limit of the second one is infinity as well, right? Even if I know that, that doesn't mean that the limit is 0. Why? Because one of them might be going to infinity faster than the other one. So just because you have a difference and both of them goes to infinity, doesn't mean that the difference will go to 0. One easy example of that would be something like, let's say, 1 over x minus 1 over x, right? And then let's say x is going to 0 from the right. In that case, notice that both of these terms are going to infinity, right? However, in this case the limit is 0. However, if I just change this 1 to a 2, right? Then what's the limit? Both of them are still going to infinity, right? But of course, what's the limit in this case? Am I making sense? This is in fact just the same as 1 over x, right? So the limit in this case is infinity as well, right? So you have infinity minus infinity in this case, but the limit is infinity. But if I had just a 1 here, then we saw 1 over x minus 1 over x is just 0, then the limit is 0, right? Am I making sense? So just because you see infinity minus infinity doesn't mean it's 0 necessarily. But here it's more complicated because we don't even know because x goes to 0 from either side, it could be plus or minus infinity, both of them. So let's I just want to make one more comment here, that when x goes to 0 from the right, this is going to be infinity minus infinity. When x goes to from the left, it's going to be negative infinity plus infinity. So either way, you're getting infinity minus infinity. Once again, that doesn't mean the limit would be 0. So, okay, so what do we do here? So, like I said, I have no clue what to do. So what do? I just do the obvious algebra that I have in front of me. So the first obvious algebra here is that I have two fractions. I combine them into one. So what is that? What would be the common denominator here? X times radical x plus 1. Everybody agrees. The numerator in the first fraction is 1, so that will be multiplied with something. The numerator in the second fraction is 1, and that will be multiplied by something. So what goes in the first parenthesis? 1. And what goes in the second parenthesis? Okay, very good. So then what we have is the limit as x goes to 0. I have 1 minus if I distribute the negative, what do I get? Radical x minus 1 over x times root of x plus 1, right? You guys agree with that? Oh, this was a whole... Okay, so this would be the whole thing, right? And this would be a plus 1, sorry. Okay, so that line was hiding from me here. So, okay, so this is what we get. And now what's happening? If I plug in x to be 0, what do I get? If I plug in x to be 0, I see that I get 0 divided by 0, right? And when I get 0 divided by 0, what's the trick? try to get rid of the factor in the denominator which is giving you 0. Which factor is giving you 0? X. So my goal would be to get rid of x. Now, how do I do that? Well, remember I said whenever you have radicals floating around, what trick do we use? Rationalize. But in this case, I have 2 of the root functions, right? Which one do I rationalize, you think? What's that? Actually, the numerator. If you this radical here is a one whole radical, right? So don't use rationalizing with that. Use with the one on top in this case. So you're going to multiply this by 1 plus radical x plus 1 over. The thing is, radical of x plus 1 does not become 0 when x is 0, but the numerator becomes 0 when x is 0. That's why you're going to rationalize the numerator. So this would be this. And now if I multiply out, what do I get? Well, in the numerator, if you multiply out, you're going to FOIL. If you FOIL, you're going to get 1 minus x plus 1. And then in the denominator, you're going to get x root of x plus 1. Don't multiply out at all. 1 plus root of x plus 1. In the denominator, do not multiply out. Okay. You guys agree with that? When you FOIL in the numerator, you're going to get the square of 1 minus the square of the root of x plus 1. That's what you get. You'll see that I can get rid of 1. And if I get rid of 1, I get negative x over x root of x plus 1. 1 plus root of x plus 1. And I can cancel out the x's now. And if I plug in 0 now, what do I get? What's that? Everybody agrees with that? Negative on top, yes. Negative half. Now, if you think about this problem, what percentage of the problem was algebra and what percentage of the problem was doing calculus? Yeah, it's a lot of algebra that you're doing, right? So, again, that's why you need to be good at algebra in a calculus course. Okay. If you forget algebra, if you're not good at algebra, if you didn't work hard in algebra in high school, that keeps punishing you as you take any math class in college. Okay, so I get negative half. Any other questions? Yeah.
33 on 1.5. I'm sorry, 35 on 1.5.
Okay.
The limit and x goes to 2 pi to the right.
The limit x goes to 2 pi from the left.
And
X times cosecant of x. Okay. So I am going to take the limit as x goes to 2 pi from the left. Notice that cosecant is the same as 1 over sine, right? So x over sine x, that's what I get. You agree? Okay, let's now analyze what's going on here. Let's find the limit of the numerator and the limit of the denominator separately, okay? The limit of the numerator is 2 pi, right? X is going to 2 pi, right? X is going to 2 pi, so the numerator is exactly x, so it's going to 2 pi. What's the limit of the sine x? Now you have to think about this. X is going to 2 pi, right? The angle 2 pi. So think about the angle 2 pi. Let me make a okay, let me make a circle here just to remind you what's happening with mine. Okay, so let's say I have a circle, and here's my x-axis, here's my y-axis. Now think about x is going to 2 pi, right? So the angle, what's the, I can assume that x is close to 2 pi, but less than 2 pi, right? X is less than 2 pi, but close to 2 pi. So what would be the position of the terminal side of x? The terminal side of x would be in which quadrant? Fourth, right? The terminal side of the angle x will be in the fourth quadrant, right? So as x gets closer and closer to 2 pi, so that means x is getting closer, the terminal side is getting closer and closer to the x-axis, right? Which would mean that the sign value is getting closer and closer to what? 0. So the sign value is getting closer and closer to 0. But on top of it, what is the sign? Is it negative or positive? Because the angle is in the fourth quadrant, sign should be negative there, right? Because if you look at the intersection with the circle, the second coordinate would be negative, right? So we know that that means that sign would be negative. So what do I have? I have numerator becoming 2 pi, denominator becoming 0 and negative, right? So what is that? It'll be negative infinity. Is everybody okay? Questions? Okay, anything else? Anything else at all? No? Okay. Here's I am going to be we looked at many kinds of limits so far, but this would be another kind of limit. So this would be limits at infinity. So the kinds of limit that we are going to look at here is that the limit as x goes to infinity of a function f of x is equal to some number L. So if we write this symbol, what does that mean? Well, so what it means is that f of x can be made as close to L as we desire by taking any x larger than a sufficiently larger than is then a sufficiently large number n. So what does it mean? It means that, let's say I have a number line here and another copy of the number line here, and let's say here I have the number L, and I want, say, can we make the value of f of x to be within any small number, let's say epsilon. So epsilon is a very small number, and I want f of x to be within epsilon of L, no matter how small this epsilon is. Can I do that by finding a large number n, such that for whenever x is bigger than that, whenever x is bigger than n, f of x is within epsilon of L. Am I making sense? So I can make f of x to lie within any small number by picking x large enough. If I say it loosely, what I should be saying is that as x gets bigger and bigger, okay, the value of the function is getting closer and closer to L. As x gets bigger and bigger, the value of the function is getting closer and closer to L. That's like a imprecise way of saying it. You probably now expect me to say also that, we have a limit as x goes to negative infinity of f of x, right, equals to L, and that has a similar meaning. So this would mean that as x gets bigger and bigger and negative in the negative direction, the value of the function is getting closer and closer to L. Okay. So let's look at a few examples to explain these things. For example, if I take the limit as x goes to infinity of 1 over x squared, what's the limit? Well, in this case, what's happening? The denominator is becoming larger and larger. The numerator is fixed, right? So ratio becomes what? Smaller and smaller. So you expect this limit to be 0. And in general, that's true. Whenever you have a fraction, the numerator has fixed limit. The numerator, the numerator has fixed limit, but the denominator is getting bigger and bigger. That is, the limit of the denominator is infinity, right? Here, what's the limit of the denominator? It's infinity. So whenever the limit of the numerator is a fixed number, the limit of the denominator is, fixed. Fixed number, and the denominator is the limit of the denominator is either infinity or negative infinity. The limit would be 0. Let me say that again. If the limit of the numerator is fixed, if the limit of the numerator is a fixed number, the limit of the denominator is either infinity or negative infinity, the ratio would be going to 0. Okay. So similarly, what's the limit as x goes to negative infinity of 1 over x squared? 0 as well. What's the limit as x goes to a negative infinity of just 1 over x? That's 0 as well. Okay. So what I said then is that if you are looking at the limit as x goes to infinity or negative infinity, and as x goes anywhere, I guess, if I take the limit of a ratio like this, if this guy, if the numerator goes to a fixed number, and the denominator has limit plus or minus infinity, then the ratio will have limit 0. Okay, so that's what you want to remember. It doesn't matter what star is. It could be a star, could be plus or minus infinity. A star could be a number. What I'm saying, the limit of the numerator is fixed, limit of the denominator is big, then the limit of the ratio would be 0. So generally, if I take the limit as x goes to infinity of 1 over x to the r, where r is positive. If r is positive, then that means, if r is negative, then it is actually what? Actually some positive power, right? So right now, the limit would be 0 because the denominator is getting big. Okay. Here's another example. What's the limit as x goes to infinity? 3x squared minus x minus 2, and I have negative 5x squared plus 4x plus 1. Okay, so what's going on here? What would you expect the limit of the numerator to be? What's the limit of the numerator? It's hard to say because if I look at the numerator, right? What's the limit of 3x squared? Just 3x squared. When as x goes to infinity, what's the limit of 3x squared? Infinity. What's the limit of this guy? Negative infinity, and this guy would be just negative 2, but you have infinity minus infinity, right? Am I making sense? But what's the limit of the numerator? The limit of the numerator would be infinity, in fact, because this guy is much bigger than this guy. Okay. In other words, notice that if I look at the numerator, I can factor out the numerator in this way. I can factor out an x, okay, and then I can write it as 3x minus 1 minus 2 over x, right? If I just factor out an x. You agree with that? From the numerator. So notice that now as x goes to infinity, right, this guy is becoming large. This guy is becoming large, right? Infinity. This guy is just minus 1. This guy is minus 0, right? You agree with that? So now I have, inside the parenthesis, the expression is going to infinity altogether. The other factor is going to infinity, so the entire thing will go to infinity. Am I making sense? Now, I don't really have to do that to know that the limit is infinity. Whenever you have a polynomial and you are looking at the behavior of the polynomial when x is big, negative or positive, then the only term that matters is the dominating term, which is the largest power of x. Okay? So if you are looking at the behavior of a polynomial function, all you have to do is look at the dominant term. Okay? So if you look at the dominant term here, when x is big, the x squared is big. So the limit of the numerator would be infinity. It will be determined by that term. Am I making sense? So we know that the limit of the numerator would be infinity because the dominant term is going to infinity. And what's the limit of the denominator? Well, all I have to do is look at the dominant term, which is negative 5x squared, and the limit is what? Negative infinity. Well, what's the limit then? What's that? Okay. The answer is neither. Okay. And I am glad that somebody said negative 1. Okay. Okay. Remember this. If you have infinity over infinity, it's not 1. If you have infinity over negative infinity, it's not 1. Infinity is not a number, right? You're not dividing infinity by infinity, right? What this is when I'm writing infinity over infinity, I'm expressing the idea that the numerator is becoming large, the denominator is becoming large, right? So doesn't mean that the limit would be 1 or negative 1, okay? Why is that? Well, let's think about it for a second. Let me give you, well, you know what? I'm going to stop just right here. Oh, I didn't realize I just answered one of those questions in the class today. Who asked that question? You did, right? Okay, you're not allowed to ask any more questions.